All right, if you guys are ready, I can start if you guys are ready. So just out of curiosity, so far based on everything I have said, has it made anybody more curious to try and mine if they haven't already, or less wanting to mine?
Considered Ethereum at one point too expensive to stake.
Right.
That's too much.
Right. And yeah, again, it's like more and more expensive the longer you want to get into it. But at the same time, I've found, at least from my experience, that the reward is only if you kind of get in early, or if the cost or the price of that coin suddenly jacks up again. But again, then you got to be able to get on an exchange where you can then convert it to actual a means to actually be able to spend it on something, whether it be actual dollars or somebody else is going to accept things as well too. So as I'm talking about this more, I was thinking to myself, because I've just started exploring this whole space with NFTs, because it seems like every other news article these days is talking more about NFTs, which is not a cryptocurrency, but it's I don't even know how to properly explain what an NFT is specifically, but it's basically taking something and digitizing it so that you could own it. And the way I saw somebody on a YouTube video explain to me, which made more sense to me, is that I don't know if you guys play video games, whether it's Fortnite or World of Warcraft or whatnot, but in those games, people will sometimes pay money to get certain things to accessorize their avatars or their characters in the game, whether it be this fancy one-of-a-kind helmet or this shiny sword or whatever it is. And so this guy in the YouTube video was kind of talking about this, where you can kind of take that and apply that in sort of real life, where people want to get a digitized form of a piece of artwork or an avatar or whatnot that's one of a kind and unique, that you can say, hey, this is that represents me. And now people are sort of associating value to it. Because I saw just the other day that this 14-year-old kid who was he's drawing pictures of whales and digitizing them. And that whole process of digitizing them is what results in what's called an NFT. But then people are buying these unique digital sort of pieces of artwork for hundreds of thousands of dollars. So he made millions of dollars drawing pictures of whales. So I was like, the world we live in is getting crazier and crazier. That's the way I kind of see it. So it's just weird. So it's like the more and more I see this, like, is this going to be a norm? Is, 10 years from now where, we kind of purchase these NFTs? I think something sold, it's a piece of artwork, whatever, it's an NFT. So somebody had been creating this digital piece of artwork that sold for, I don't know how many, it was paid for in Ethereum, but that Ethereum at that time was worth, I think, about 30 or 40 million dollars for this digitized piece of artwork. So it's not something that you can even necessarily hang in your home, but you just happen to own, and it's one of a kind to you. And apparently, again, this is again over my head, as to why somebody would do that, but apparently it will have its value, because a lot of these pieces of artwork and these NFT pieces that are being bought for one thing are being turned around and then resold for a higher piece, but you've got to buy the right things, and there's an element of chance in there too as to what's going to be popular, what are people going to like. So a lot of weird questions around the space as well too, but I don't pretend to understand any of it. So
a lot of scams going on there too, though, like the ape guy disappearing, like all of the money that he had sold that for. And then if you do get scammed by that, I'm going to make money from you, right? Like I think that's the most embarrassing thing, that somebody paid, thousands of dollars for a funny looking gorilla picture, and then now it's not worth anything or whatever. That's embarrassing, to be sure.
Yeah, absolutely.
It's the question of self-healing, time you get a transaction. Right there in watching it says, instead of T, there's many Ethereum.
Sure, exactly. Or is it self-dealing? Right? Yeah, definitely a lot of questions and a lot of stuff that could lead it to things like that happening. So yeah, still, it absolutely boggles me. So, but yes.
Is there a way to recover elasticity?
Correct. Yeah, you gotta.
I'm at the bank, I can go get my hands here.
Correct. If you lose your...
It's basically...
Exactly. It'll just sit there in the middle of nowhere. Yes, exactly. Absolutely true. Actually, that brings up something that I accidentally did. When I was trying to do some farming of chia, I had first connected to a pool for the first time. So for all this time, I was just doing this on my own, just playing. Actually, pools were new. They didn't have pools. So pools were just introduced. But in setting up my key to where I was supposed to, my pool, I had my own private key and I have my own public key, but then you have what's called a pool address of a pool that you're connecting to. But for whatever reason, if I hit a block, I had it pointing to some other key that I don't even know where I got from it, but it wasn't the correct pool address. So then I happened to hit a block and I was like, yes, I got it. And then when I went to go and look, my reward was sitting out in this pool address that I had no way of getting to because it was not the correct pool. So it's still sitting out there and I have no clue how or when, or if ever, I'll be able to access it. But you're right. Just like with a bank, at least if something were to go wrong, you can show your ID, prove who you are, go get your stuff. That's not the case with this. If you lose your private key or somebody were to somehow get a hold of it, you would then lose what you have. So absolutely something that's underlyingly scary in this. So, okay. So I did write this basic blockchain application. Now, I don't know if I have everything fully set up here, but all the code is here with full instructions, and I'm going to walk you guys with it. And the best part is, because I was in testing for a number of years before I switched into doing more development work, I've always sort of lived by that testing mantra. So all the stuff that I have here, I've written tests for. And hopefully that will also help you guys as you're looking at this, be able to read through my tests, which I will show you guys as we go through it, and understand what all the pieces are doing. So when you install Node.js on your machines, and again, I'll put more instructions around how to do all that and what you need to get set up, but it is very straightforward. You could then run all the tests using a test framework in JavaScript called Jest. I'm using a couple of different things, but by utilizing that, you can run the test and see what exactly is happening in the code as you're kind of playing with it. And the second thing I'll talk about is, has anybody used an application called Postman? Postman, or not before? Yep. So, or similar applications as well too, where you can make REST calls to it. So once you start up the actual server, then you can use Postman and make calls to then create your blocks, add blocks, mine blocks, and then have this actually living on different servers, or sorry, different nodes or different computers in your home or with a friend, whatever it is, and play with it to see, hey, multiple chains on different networks, different nodes, and what happens when you mine one block, how that gets all copied over and whatnot. So I showed this earlier on the slide, but this is that create block class. Look there so I can minimize some of this. Okay. So you'll see this one class, this first class here called the block class here. So each, oops, I should say block, not black. Each block has those different attributes that I mentioned. So it has the actual hash, it has the last hash, and it has this timestamp attribute. Now the timestamp I'm just pulling in from JavaScript library, but in block.js over here. And again, so I have, I should lay this out again for you guys. I have this summaries folder. So you'll see here the actual application itself. Yeah, with the actual server code and whatnot over here under this app folder. Then you'll see the actual blockchain code itself, where you'll see the block code and this index code actually in Node.js, at least, to make it easier when you're doing imports and stuff. You can call, if you have another class here, in this case, I had it called blockchain before, but if it's the same name as the actual folder name, you can call it index.js as well too. And then you'll see it. So then this is the block class. This is the actual test for the block. So, and I'll go through the summaries first, and then we'll kind of poke around in here for a second, and then I'll see if I can actually get it running or not now, because I'm actually using my son's computer when I brought everything over, and I was trying to get it all set up this morning so I can actually run it, because it was, when I wrote this, it was all working just great. So this is the blockchain code, and then you'll see this folder called Summaries that kind of lays everything out in steps, so you can sort of see all the pieces and the descriptions for how to create stuff and whatnot. And then how to like sort of get it all laid out. And then there's the blockchain code. And then this is the actual API code. So what this is the actual code for when you would use an application like Postman, or you can actually even do it in your browser, actually just putting, once you start up the server, the actual address for your server locally would be localhost, and then the port name, in this case, I had it to 3001. But then if you were to go to browser and do HTTP localhost 3001 / then any one of these endpoints, if you did /blocks, then what that would return back to you is the actual existing chain on that node, the actual blockchain, all the blocks that are currently there. And then if you were to do mine blocks over here, so if you were to do a post operation of mine, and in your request body provided with the actual request of that data and the timestamp and the hash and whatnot, it would then create that block for you. And so that's all that's there as well too. So that's all lit on the API, but let's go through those summaries first, and then we can start poking around there, and then I'll see if I can get this running so we can actually see it in action. Blocks, okay. So we were looking at blocks first. So this is that block class that I mentioned, and this is that Genesis block. So the first block of the chain, it's very simple. When you return this, make something with some dummy data, dummy hash. This here is supposed to be a dummy hash over here. It doesn't have the existing thing, and just an empty array, what it is, because it doesn't have any information to start with. Again, this is just something that I was trying to play with and try to create and do over here. So feel free to take this and build on it. If you happen to make a coin out of it, you don't have to give me any rewards or transactions, no worries. But so then that's the Genesis block. Then this is that mine block piece of it. So this is the function to actually generate a block off of some provided data. And again, I try to document everything as nicely as possible, so that if you're not familiar with JavaScript, hopefully it's not difficult to read and understand. So this is the mine block, again, taking in the piece of information to do the actual mining of it. And then, I think this is the test code over here. Yes, so if you use Jest as your test framework, the way you have it set up is when you create any files, if you name it with .test in the name, the way that it'll work in the actual project file, that it'll look for that, and it will run all those test files themselves too. So it's looking like, yeah, so Jest finds files with a test.js extension. And if you see any of those, it'll execute those tests. That way you can kind of run the test locally, sort of see how it all works, play with it, try to understand it, and then try to launch it and see what happens. So in this case, for the actual blocks, the tests I think I wrote were pretty simple, just to make sure that, so this before each piece over here in Jest, then it says to run this before running each of the individual tests. And each of the tests start with this word it that's over here. And then a little description of what the test does, and then what the actual expectation is. And then once one test is finished, it'll run this to actually do a little bit of cleanup, is what I think my intention was for this over here before trying to run the next test. Otherwise, it would goof up, especially since it's looking for the Genesis, or it was at least at one point, and then looking at last hash to see if it matches there as well too. And again, yeah, I did put a lot of documentation in here as well to sort of talk about how this all works with running the test. So I'll try and get this set up in a second to see if this works correctly, but that's that piece of it for testing it there. Now we looked at the mine block. This is the actual project and those instructions for setting up the blockchain piece of it, the application. This is the hashing function. Let's see. So yeah, so that's right. The library that I used specifically for the hashing was Crypto.js, and NPM is just a package manager. It's just a way of being able to grab other libraries or functions and whatnot to be able to add functionality to your projects. It doesn't have to just be JavaScript. It could be for any language. So it's a package manager that's used, whether it be Java or JavaScript or whatnot. But this is how you would pull down other libraries if your project depended on those. And in this case, I used the Crypto.js over here as well too. So I use that and I pull that in and use that appropriately. So this here is just basically telling it then once you pull down that library to go to this particular class, the SHA-256, and utilize that. That's over there here. And then you can see over here when we're doing our actual hashing, it's just as simple as in this case, taking a timestamp, your last hash and that piece of data, and then hashing that together to a string and then returning it in there as well too. So that's that for the hashing piece. And let's see, blockchain. So now, so that block, all those block classes are for making individual blocks. Then you'll see that in the blockchain class that we can create a chain based on that block class. So you'll see here, then of course, for the chain that we need the actual block class code. And then we can actually do the actual generation. And we can add a block just like this, where you do the whole mine block and then adding in an actual block to the chain. Now, what we're doing here is, in order to get the last hash, we need to know what that last block is. So doing that, since this is just a keyword associating with the actual class itself, says take that existing chain, see how long it is, and since in JavaScript arrays are 0 indexed, take how long it is, and then that length number, subtract 1, that will give you the location of that very last block. Then you can take that last block and then do whatever you need to do with the whole hashing piece of it. Now, I did add in some validation pieces as well too when I was playing with this. So validation ensures that any of the incoming chains are not corrupt. Once there are multiple people trying to add to your blockchain, if you've got more than one node going on or whatnot. And I think when I was playing with this, I had 2 or 3 just at the most. And again, it was more for me to understand as a hobbyist, how this all works. And I was fascinated with this whole space. So I was trying to make this work by setting up peer-to-peer servers just in my own home network and doing this. So if there were multiple contributors, how to do this whole validation piece. So again, starts with a Genesis block and then make sure that the hashes are generated correctly. So the checks that I have in here are pretty basic. First, I was just doing a check to make sure if it's a valid chain by looking to see if it had a Genesis block. And that's what this line 6 is doing over here. And then going block by block, just doing a for loop and just going through it and comparing the hash that I had in the last block to the hash that I had in the existing block, and making sure that they weren't equal, and sort of checks are in that sort of space, making sure that what was equal is equal. And I don't remember if I did another check on that there as well too, but it looks like I'm just looking at the hashes to make sure that they were in fact different between each, to do sort of my own sort of basic sort of validation. So then this method here, this block hash here, depends on doing stack block hash that's in the block class, and it generates the hash of a block based on only on its instance in the block.js. And then that's how I'm doing this whole block hash over here to do this return over here. So this in JavaScript, you can do this like this, where you can get the instance variables from a class like this and kind of grab it like this and then assign it to this. So I'm grabbing the timestamp last hash and data from that current block instance when I'm calling block hash, and which I'm doing right over here. And then from that, being able to return that back appropriately. So this is the replace chain. I kind of touched on this a little bit earlier as well too, with how this is just, again, just one way, and this is how Bitcoin was doing it, but how do you do this when you've got multiple nodes and multiple pieces of information, and how to get the longest chain. And so if another contributor to a blockchain submits a valid chain, and it says replace the current chain with the incoming one, and only replace chains that are actually longer than the current chain. Handle this with a replace chain function in the blockchain class. So I have this out there in that class, but I kind of separate it out just for documentation purposes, so you guys can kind of see this. And so in replacing it, it's looking to see which one is actually longer, and I'm logging everything as well too. So when you actually do run this, you'll see that in your log statements in your console, you'll be able to see what exactly is happening. If you, on one machine, call the mine block and you adding to the chain, then the other node to the server code will be able to sort of see that, and then it won't do anything unless that node has a longer chain than itself. And then it takes that chain and replaces it with its chain, and then it has a copy of what's there in the network. So you can kind of, it's kind of cool when you kind of see it all happening and how it all sort of connects together in that regard. So that's what that replace chain is doing over there. And then again, I did have tests for almost everything. So when you get that set up, if I aren't able to do it right now, but once you do set up and you run all the tests, you'll see it all happening, and you can just go in and fiddle with it. You can come in here, you can do some console statement, you can do some logging, you can take a look and just sort of see, and it's very simple. Once everything's in, when you do run test, the actual package file, when you call this npm, when you do the actual test call, will then has the actual command for running jest. So then jest will then execute and then run all these tests. So then this here, this for the blockchain has tests here for actually adding new blocks, making sure that your chain starts with the Genesis block. But yeah, so then you can sort of see that. So in jest, you can sort of see that when you have sort of like a higher level test framework function, you call it describe. Then each of the tests, you just started with it, and you kind of use that link for jest. So it starts with the Genesis block. It adds a new block, and then you can add your own test as well to see what's happening there. So, and then I have these tests here again for chain validation, but I'll let you guys look at that after. Okay, so we talked a little bit about the blocks piece of it. So there really is just two endpoints that I think I had. One was an actual call. Yeah, that's right. It was just two endpoints. One is if you do localhost :3001 in your browser, once the actual server is up, once it's running, and you do that /blocks, you'll see what the existing chain looks like on your particular node. And then if you were to call the mine blocks endpoint, so it's going to be the same thing again, localhost :3001 /mine, then you will see, and then you provide a data. As part of that request, for any post call, an HTTP request, you got to give it a request body. Everything is in JSON. And so if you put your data in there and do an actual mine, then you will see that your block got added. So once it got added, and then you were to call blocks again, then you will see that your chain is actually growing with a new block that you just added. I think, and I put instructions here as well too. So with Postman, you can open up a tab, or in a browser, use Postman, and then you just had to pass in some sort of data. It'll grab the timestamp and everything appropriately, and it'll just add it in there. But just like this. What you would do for the endpoint. Okay. Then let's see, I had server code, which I wrote some time back, but this server code here is actually, it's just always listening, and it's listening on a particular port, and it'll connect for peers, and it's looking for peers on the network as well too. With this, now I'm trying to remember the specifics, but that's why it's always good to document. So it's good to have all your notes here if you come back and look and see what you did. So the same class that creates the original WebSocket server will be used to connect to existing servers. And then once you set up your server with that port, it will be listening over there to see if there's any other nodes of the blockchain that are on the network, and then connect to then sort of see if there's any changes that are happening. And then, let's see, allow the sockets to send message to each other. And then, so I have a message handler class over here as well too, and this connect socket. So once it's actually connected and messages are shared, you can sort of see that. And again, one thing you'll notice is that none of this is particularly complicated. Most of the code are all small functions. I don't think altogether there's even like, I want to say 300, 400 lines of code at the most that I've written over here, but all sort of small pieces. So describing this basic functionality of how a blockchain works and how to keep adding and manipulating information on this blockchain. So, so that's here on the peer server. The other thing I think that was interesting to look at is with the WebSocket module, you can have real-time connections with multiple users on the blockchain. And I don't know why I eventually decided to use WebSockets. You can actually use anything, but I thought maybe that was probably the easiest one to use. But this, again, well, it's all outlined here. And so with the server, it's all listing over here, and it's all connected. And then I thought I wrote tests for the server too, but I guess I didn't for this, or I've got to clean up my code and make sure I have tests for that as well. So then this here is the synchronized chain classes, and it's going to use the receive chain to synchronize these chains across all instances with that replace chain function that I mentioned earlier. So this guy will call that guy and then replace it appropriately if there are longer chains out there. And again, this whole exercise was just a means of trying to understand how the blockchain works and if I could implement my own. And really, if you were to go and look at, so the code is open source for most of these coins that are out there. So I know for sure for Chia, and I know for Bitcoin, I'm almost positive it's all open source as well too, but you can actually go to the Chia project, which actually we might do shortly just to show you guys, and see that a lot of what they're doing, you can just look at the code. It's all open source. You can even contribute to all these projects as well too. You'll just put out a pull request, and then if they think it's valid or acceptable, they will merge it to the main code branch, and you could be part of these projects as well too as a developer as well too. So I actually did do a pull request for Chia for a tool that they had. It was a side tool, and it sat out there for a long time until somebody got around to looking at it, but then it was accepted. It was just a small change to make things go a little bit faster because of a bug that I was finding locally, because Chia is a lot newer than other things. So there's more bugs and stuff in the code as well too, which is actually another good point. You're kind of trusting that the validity of the code and everything is sort of secure from that point of view as well too, since it is all just people that are writing this together. But a lot of these organizations, at least with Chia now, they are actually hiring people as well too to help maintain and develop and keep everything sort of clear and clean. But the point I was trying to make is that if you go and look at their code for how their blockchain is and what they're using, it's not that much different than this, except they have other information that they're using as part of that blockchain. So if you were to go out there and just look up Chia code or whatever it is, it'll take you right to that Git repository. You can pull it down locally, and you can actually take a look at how that's all being implemented and what they use, and look at Chia's white paper, or you could do the same thing with Bitcoin as well too. So again, the point I'm trying to make is that none of this, what they're trying to do is make it all transparent and try to make sure that anybody can kind of take a look and see and make sure that things are sort of valid. And you've got many, many eyes looking at this when there are changes and things being made. So now I was trying to do, I think, my own sort of difficulty sort of level with the proof of work algorithm with what I was trying to do. I don't know how successful I was with this, but I know it worked. And I know that I was able to adjust the difficulty for how difficult it is to allow things to be mined by sort of introducing an artificial way, very basic way. So not the true proof of work algorithm, but my own sort of proof of work algorithm based on just giving sort of some time frame or whatnot with it to allow it to like make it seem like it was difficult, just to sort of test how this works. But it is all organized in its own sort of piece of code and its own classes where you can go in and make your own sort of algorithm for how you wanted to make your coin work in terms of how that proof of work algorithm should work for that. So I have this dynamic difficulty piece here. So this difficulty adjusts. Oh yeah, that's right. And so this will keep changing as more miners are added to the blockchain. So in that config class or config file that I have, there is a mine rate constant there that represents the millisecond rate that blocks should be mined at. So that's what the rate that I have over here in that class. And so you could make it more difficult. So people are just sort of kind of trying to mine and mine and mine, and then artificially then, hey, you've been rewarded. And you know, once that certain amount of time has gone by, but again, you could introduce your own algorithm. And so if you were to look at that Bitcoin white paper, you'll see how that's being implemented in code form. If you were to go to the actual Bitcoin open source code repo and see how that looks and how that actually works. But you could, again, if you make your own coin, you can make your own sort of proof of work algorithm for it. And again, I do have tests for all of that stuff as well too. So then after that, the proof of work stuff, I've got all the wallet stuff over here. So I think we'll look at that create wallet first. So again, so the main pieces again of most cryptocurrencies is that you need to have a means of being able to mine, you need to have a blockchain, and you need to have a wallet. So with this wallet, so wallets will store the balance of that individual, and it will approve transactions by generating these signatures. So in the default, that wallet file, there's the wallet class in that wallet folder that we'll show you guys in a second. And every wallet will have 3 fields: a balance, which is initial balance. That's a variable that will be a value that every wallet will start with to get that economy flowing. And then they'll have this key pair object, and the key pair object will have methods that can return the private key and stuff for the wallet, but that will only be for you locally if you were to call that on your instance to be able to get your private key if you needed to. So, and that's the same way it works right now for Bitcoin, Chia, Ethereum, and stuff. When you've got it all set up locally, you can get if you've forgotten, you can get it locally. But if you somehow lose your system, something got erased, you're able to get that actual set of keys, then yeah, you are in trouble. You wouldn't be able to access your wallet anymore. And the private keys are actually different from coin to coin is what I've noticed. So in Bitcoin, it is just a hash, a 32-bit hash, but in Chia, it is actually a list of 24 English words. So you have to put those, that's your private key. You got to put those words. It could be dolphin, calendar, dog, dingo, and I'm not even sure where all the words are pulled from exactly, but you got to put those words in the right order, those 24 words, and that's your signature. So by utilizing that, then you can use that as your private key and then get what you need. But they assign that to you. Once you download Chia, you get it set up, you get it installed, and you create your wallet, then you'll be given your own private key, which is those 24 words. Okay, so then, yes, and again, I have to stress this as much as I can. The code is relatively simple in terms of number of lines of code. So when you look at this, you'll kind of see, okay, it's actually not that bad and not as daunting as it would seem when you are trying to create a blockchain. So then I got a bunch of different tests for the wallets here. So a test to make sure that this input object was created along with the transaction in that transactions class. And then just to make sure that that's correct when you're sending something in. And I have some more tests that are there as well too. And then finally, in these last two things here, we got this whole idea of a pool. And again, the whole pool piece again is when you have multiple people working together to try to find a block. So you can, different sort of exchanges, or it's not exchanges, in different cryptocurrencies, Bitcoin included, but it'd be next to impossible if you're trying to mine on your own. That's why people are pooling together there. But for other coins, depending on how much, like you guys saw how many hard drives I had, that's like a fraction of what a lot of people out there have. They have a bazillion different drives and who are mining. And so they're doing it solo because they think they have enough hard drive space to have enough of a farm that it's more rewarding for them to just, because if you join a pool, whoever is running that pool, and I should mention that as well too, pools are usually organized and there's a reward given to the pool owners, I should say, where they're organizing it, making sure that that's running smoothly. And so they get a piece of those rewards as well too when you have people joining those pools. So in fact, one thing I think I can show you guys with Chia at least, because it's a lot more transparent. One of the big pools out there for Chia is something called Space Pool. And you can actually see how much space is out there. And this is one big pool that somebody is running it, but it's kind of the big pool that's happening right now. Is that, oh wait, you guys can't see my screen, sorry. Zoom share. Try to do share screen. Yeah, there we go. Okay. So this is, okay, this is actually a good example to kind of talk through. So this is for Chia. And if you're mining Chia, you'll see the whole analogies and whatnot, whereas with Bitcoin and whatnot, it's all about mining and whatnot. Chia is all about farming and being green and not using as much electricity because you're using more space. And in fact, with my electricity bill, it's a fraction of what it was before. I think that cost has gone down, but the cost of buying a hard drive is expensive. Like a 10 terabyte hard drive is like $300. So at that time, I was like, you know what, let me try this as an experiment with the idea that if it doesn't work, I could sell these. But then when Chia tanked in price, everybody was trying to sell their hard drives. So now I'm just hanging on to my hard drives for now. So if anybody needs any hard drives, just let me know.
So I work in a storage company. They've been making a big deal about Chia. Obviously, it's a big disruption.
Seagate?
I mean, I don't work on Chia drives. I work on enterprise drives. But so if you're trying to make hard drives for Chia, would power consumption be the biggest concern there, or what would you sort of target?
That's a good question. So hard drives apparently don't use nearly as much power as GPUs. Yeah. Not even close, because my electricity bill has gone back to being very close to what it normally has been for just household usage, even though I've got 50 drives running in that, more than that actually, maybe about 60 drives running in that rack.
They all spinning, yes?
They're all spinning at the same time. Yeah, they're all spinning, and there hasn't been much electricity use at all. So from that standpoint, that cost has not been impactful like it was, at least when I was trying to mine Ethereum or Bitcoin. But yeah, so that's a good point as well too. One thing, since you work in that space, I've been curious about this. So at least with Seagate, not so much with Western Digital, you can go and buy an enterprise drive for, I don't know, let's say a 12 terabyte drive, $500, whatever it is. Or you can buy, Seagate has its consumer level, just the external drives that can sit outside that you can plug into USB for $300. Now, I don't know if this is a known secret or this is just known, but then because I had those racks, I was buying those consumer level drives and just prying open those boxes. What I found inside were the enterprise drives. Those $500 enterprise drives are inside those $300 consumer boxes. So you can either just go buy the enterprise drive without the case, or save $200 and buy the consumer level external ones, pry it open, take the pieces off and stick it into your drive as well too. So I was like, is that like a secret? Is that something that's...
It could be a lot of things. So the external drives, they don't actually have to operate as fast as an internal drive because you're operating over USB. It's really slow interface relative to NVMe or even SIMCA.
Sure.
They might be doing what's called binning, where when we manufacture this stuff, it's not reliable, the outcomes. And so you're going to end up with some that are worse than others. And they might just be putting the crappy ones in the external.
The crappy enterprise ones in there. Yeah. Interesting.
But, I don't know for sure. I've only ever worked in enterprise solid state, so I don't know anything about spinning this currently.
Got it. Okay. Because I was like, it was almost like a jackpot. I'm like, what? What are these enterprise drives doing in these consumer level boxes? But then as I was opening more and more of them up, they were all like that. So then I was wondering if that, maybe it's just like what you said, even though they're labeled enterprise drives, maybe they don't perform as well as the true enterprise ones.
I imagine a lot of that's mitigated though, if you're doing a lot of great stuff, right? A lot of the unreliability stuff, you got a lot of workarounds built in. So
sure.
It still might be the way to go is to get those external drives, just pry them open and toss them in your rack.
Right. So right now for Chia, at least, the global net space is 35.23 EIB. Now, I always get this confused. Let's Google it again. So EIB and TB. So one EIB is that much terabytes. Yes. Can you guys see that? This is 1, 2, 3. So it's about 1 million terabytes. So that's how much space is out there in total for all of Chia at the moment. So right now, this is the global net space. Spacepool itself has 4 of those EIBs at the moment. And at the moment, there's about 46,000 farmers. Again, back to the analogy of farming and whatnot, not miners, but we're farmers. That are out there that are currently farming and plotting at the moment. So given with this, that what they're saying is at the moment, it just takes 161 seconds to win. And the thing is, when you're part of this pool, every 161 seconds, whoever hits that actual plot and gets that reward, then the other 46,645 people would also get a piece of that. Now, mind you, it's a very, very tiny piece because you start off with only like those 2 plots. In fact, XCH is the code name for Chia. And you'll see that so far, let's see, in 24 hours, blocks farmed is 512. And I don't actually, let's see what this luck piece means actually, but they're saying that they farmed. Now this has got to be, I guess, over the course of a day. Oh yeah, it is over the course of a day. This is for 24 hours, I see. Of course of a day, but that's shared amongst all the poolers. So the thing is, what I've learned is that at least with farming, if I'm doing it on my own, eventually I will hit a block at some point. You can actually go, in theory, you can go on forever and not hit anything if you have a very small piece of net space. But if you have some space, you'll eventually hit something. But by pooling and joining a group of other people, you kind of take away that luck factor because then you're incrementally getting pieces. And in that same estimated time that you think you would be able to win something. So actually, well, I'm going to kind of jump around just a little bit. Let me go to Chia calculator. You still see this? Okay. So one 10 terabyte hard drive can store roughly about 106 plots. I think that's about right. So one drive, about 100, let's say 110 plots. Today, if you only have 10 plots, so just if you had like a small piece of drive, it would take you 22 years before you would hit a block if you're trying to do this on your own. If you have 100 plots, then it takes about 2 years. If you have 1,000 plots, then you'll see now it takes about 3 months. Now 1,000 plots is 10 hard drives. And as I mentioned, one of these hard drives is about $300. So you're already talking about spending $3,000, $4,000 just on hard drives alone to try to hit a block that you might hit within 3 months that at the moment is probably worth only $150 per block. So you can kind of see that there's no real value in trying to do this unless the actual price, oops. Oh, by the way, this is where you would go if you wanted to install the Chia blockchain on your machine locally, or if you want to see the actual source code and everything as well too, and compare it to that thing that I had created, you can kind of see all the parallels and whatnot. Let's see, try that again. Chia cryptocurrency price. That's what I want. Oh, is there one from market? Usually, there we go. That's what, yes, you can see 151. But at one point when this first came out, I want to say maybe was this, oops, been like a year ago when it first came, it kind of shot up and sat at like 1,500 before it kind of has been sitting down at the 156 mark. But you can see it's slow decline. So, but it was exciting when it first came out. And because again, a lot of these cryptocurrencies, when you have sort of the name behind it, then you hear about it more in the news and that's what's driving it up. So the creator of BitTorrent, ooh, you know, there's something that people can kind of connect with, means that maybe this will have some validity. But again, it almost feels like you're just throwing the craps dice and just hoping to see what's going to happen exactly. And there's no real rhyme or reason to it. What they're trying to argue about, though, is that with cryptocurrencies, the way that they're created, that you can use them in certain instances to power different things. So one thing that's interesting is, even though Bitcoin is supposed to be the type of currency where you would keep your wealth in there, there's other currencies and stuff too that are supposed to be for other specific purposes. Chia, I don't know if they figured out what exactly that's use is supposed to be, but there's this other one called Helium. Have you guys heard of Helium? Have you heard of Helium or not? It's been getting more and more popular because it's easy again to get into, where if you were to buy a Helium miner, and again, there's a big wait list for that though. If you were to try to get on the wait list, I think you're a good 8-9 months out before you can get one. But if you have a Helium miner and it acts like a hotspot almost, and you have other Helium miners that you can connect to, you generate currency by people connecting to your peer-to-peer network to do their Wi-Fi, their hotspotting. So it's supposed to be a way of powering that across the country if you get enough Helium spots, I guess, getting passed around and whatnot. So that's supposed to be, again, another sort of interesting space to look at as well too, but it's difficult to get into it because there's a long wait list to get an actual Helium miner to be able to do all that. So sorry, I kind of went completely off tangent here. So I was just trying to show you guys with this is like 10 drives. If you have 10,000 plots, then you're talking 8 days. So it's becoming a little bit more like, hey, realistic, but then 10,000 plots, how many hard drives is that? And what's the cost for all those hard drives? Does that make sense anymore? But if you do this on your own, the expected time is 8 days. And again, you might be lucky. And that's what when we saw over here, there was like this luck factor here. You might get lucky and then happen to hit an actual block and find it sooner than that 8-day time frame, or you can take much longer. But typically what I've noticed is that it averages out. So maybe I'll get lucky and hit something in 5 days if I had this many plots, or if it'll be longer, if it's something like 12 days, but it averages out roughly to 8 days. By joining a pool, in theory, is what happening is as you're slowly accumulating pieces and pieces of that Chia, you'll eventually get a full Chia reward in this time frame. So joining a pool takes away that luck factor. But if you have enough plots, you can kind of gamble on the other side and try and see if you can hit more blocks than you would otherwise gain from joining a pool. So that's kind of the point of sort of why this is like this. So you'll see again, 161 seconds, there's this many farmers out there. And so you'll get a piece of it and it actually tells you. So if every 10 terabytes, is actually gigabytes, but excuse me, you'll get 0.002. So that's very, very, very little, but it adds up. And over time, if you have a lot and you're connecting, it's almost sort of the smarter way to go, because then you don't have to rely on luck as much. But if you're feeling like, gambling a little bit and you have enough plots, it's not a terrible idea if you want to go solo. Or you can also, with Chia at least, you can actually pool some of your plots and put them in a pool, and you can also solo as well too. So you'll see actually in real time it's showing, and this is where that transparency piece is with the whole mining and whatnot. You can see that right now that somebody, oh, that's right. And I mentioned before as well too, when you're part of a pool, the pool also takes a fee. So usually 2 chias are rewarded every time you hit a block. If you're doing it on your own, you get the full 2. If you're part of a pool, the 1.75 or 1/8 of that goes to you, and 7/8 of it would go to everybody else shared amongst those 40,000. But you can see at this very moment, in the last whatever 13 minutes, 18 minutes, 20 minutes, different blocks were discovered, and so the rewards are being shelled out at the moment. And there's probably time again, as he was asking before, for things to get synced up and for that to work. So then you'll see. Next to, at least for this luck piece of it over here, this extremely lucky, very unlucky, and whatnot, it kind of ties to whether that person, and when I say that person, I mean their actual public wallet address, recently hit a coin. And then whoever this person is, and it's probably a different person, farmer, there we go, that's the farmer. And it is, because you can see from their public key that it is a different key, but they must have hit coins like on a higher rate than what's expected to for the amount of space that they have over there. So this is an example of a pool. So I wanted to kind of show you guys what that looked like, at least for Chia as well too. Bitcoin is as transparent, but because Chia is newer, they've made it nice and cool looking and cleaner. And so newer pools are joining and trying to sort of maintain that sort of look and feel to make it more attractive to come and see what's happening. But again, with the price tanking as well too, it doesn't make any sense. I would not advise anybody to try and do Chia for now, at least as well too, because it's so expensive to get hard drives and whatnot to be able to do this, and you would not get anything back, because I don't see it, at least in the short term, increasing in price there. So, all right, let's go back to the code. Okay, so again, there's code I have over here that talks about how to set up the pool, and all that stuff is written over here. So if you were to take this code, it's all described here, and I'm actually going to clean this up a little bit with some additional instructions. If you have a laptop and another laptop, or a friend who has a laptop or whatnot, and you guys would have both run this, you'll see how this works. And you can see your blockchain. You can add information to your blockchain, and you can remove, actually you can't remove blocks, but you can add things. You have to reset everything if you want to start all over again. But then you can actually see how that all works. And it's fascinating just to kind of play with the code to see a blockchain in progress and be able to contribute to it. And then I strongly advise then, once you kind of get familiarized with this, to then also go look at the Chia source code, the Bitcoin source code, just to kind of see, hey, this is how they're implementing it. And it's not really much different than what we have over here. So there's more stuff here on handling the peer-to-peer stuff. And then I'll let you guys kind of go through all that stuff with the transactions. And finally, the actual miner piece of it over here. So like, this is just the constructor for creating that actual miner itself, and being able to create the actual, connect to the server and have the wallet and connect to the pool, and then having the actual blockchain, and then actually grabbing the actual valid transactions. And again, this proof of work that I've implemented here is tied to time and the amount of time, just as an artificial way to be able to see and do all of that. But again, you can go in there and you can make any sort of algorithm that you want in terms of complexity and to understand that. So and then let's open up the other code. So yeah, that's that. I think we're at 11:30, but any questions? Was this useful? Did you guys learn stuff?
The beginning you mentioned like a similarity between this and the ledger. And so the ledger, I mean, to think about a bank ledger that's data, right? You can parse through it now, where you get the data not trying to reach each other.
Yes.
Is that something you can get here too? Or how do we do that? It's all kind of depending, you know, how do we read the whole thing and say this makes sense?
Yes, that's an excellent question. So a ledger, again, will have all the transactions, and the bank would have a ledger of all the transactions that its customers would have in buying and selling or whatever it is. That exact same ledger is represented by having the actual blockchain. Each block would show all the different transactions that, so a person will then mine, or just, this is the part where it definitely is very confusing. You find a block. That piece of it is separate from the transactions piece, in that the transactions still happen, but then those transactions are put in this newfound block. And a block could have a certain number of transactions. And somebody mentioned that in Bitcoin, it's actually capped at a certain number. So this ledger of transactions is what the blockchain is, this chain of blocks that shows all the transactions that have happened thus far. So in our case, like you said, hey, but there's different nodes everywhere. Those nodes, those chains in each of those nodes should be identical. And in the case of Bitcoin, Chia, Ethereum, Polkadot, whatever it is, there's a website that you can typically go there and you can see the entire blockchain and the ledger. And you can search through it, you can look through it. The only thing is that it's going to be made up of public addresses and whatnot. It won't have any names or anything. So, but you could definitely go and say, hey, punch in your address or somebody's address, and it will then search and see, hey, this guy moved this much Bitcoin at this time and got this much Bitcoin at that time and blah, blah, blah. But you can see every single transaction by that wallet address. So by seeing all of that, that's supposed to be the quote unquote ledger that's supposed to be public and transparent and available in all the different nodes. If that makes sense.
If I'm doing something, does it have to be, this could be, can I just have one machine where all my data is? I'm just doing this for myself.
You can, for fun. It wouldn't have any value per se, because then nobody would accept your coin until you.
Yeah, I'm just thinking about transactions. I want to pick my one bank account, download it and put it in the blockchain. I would just have it on my computer.
Oh, sure.
That's still blockchain.
Yes, absolutely. Yes. The idea of blockchain isn't something that's tied to cryptocurrency, but that's what cryptocurrency is using for its transparency of using a ledger. But blockchain technology, what you guys will see, as if you were to go just to Indeed and do a search for blockchain engineers or job postings in that space, you'll see blockchain technology is now slowly becoming more widespread outside of cryptocurrency. And so you'll see it in different areas, and they're looking for people who want to learn this technology, understand this technology. And so it wouldn't be a bad investment to kind of understand and be familiarized with it so that you can potentially look at any jobs that you're interested in.
That's probably all we have time for. Thanks for being here. I'm sure Alan will stick around for those who are here to answer any questions.
Yeah, absolutely.
But we'll wrap up the official seminar and let people go to lunch. I know some of you got to go to class. So thanks for those of you joining online. Thanks for being here. Thank you, Alan.
Sure. Thank you.